Hello students, welcome to this video tutorial on the surface area supernode, part 4, other triangular prisms. So let's try to determine what's different about this triangular prism compared to the previous one we did in the last video. So remember that in the last video we had a scalene triangle as the base where all three sides were different. We'll have a look at the model here, the 3D model that we have. Look at this triangle. We have a base here on the ground of 6 centimeters. We have this slanted edge as 6 centimeters, and we have this slanted edge also at 6 centimeters. So what type of triangle would this be? An equilateral triangle. All right, so let's imagine what this 3D diagram would look like in 3D space. This is what it would look like drawn on Sketchup 8. So we see here that we've got our equilateral triangle, 6 centimeters, 6 centimeters, and 6 centimeters. And of course, this is very important when we go to calculate the area of the triangle. This is the height. Let's have a look at the rectangles that kind of connect the two bases together. We have a 6 by 7 rectangle. We have a 6 by 7 rectangle. And we have a 6 by 7 rectangle. So all three rectangles that join the two bases are exactly the same, what we call congruent. So that's really going to help us when we go to calculate the surface area. So if we were to open up this triangular prism, what do you think it would look like as a net? Well, this is what it would look like. Okay, so at this point, could you please press pause and draw a rough diagram of this net? Please don't draw it too big so that you leave enough space for your calculations. Okay, so let's begin our calculations. So let's start with the triangular base. Okay, much like we did in the first one above, let's start with triangles. So we're going to start with area of the base equals, and because it's a triangle, we have to use base times height divided by 2. Now I'm not going to put brackets around it this time. All right, so let's see what our base and height are. So the base here and the height meet at 90 degrees. So the base is 6 centimeters, and it looks like the height here, this arrow, has it at 5 centimeters. So base equals 6 centimeters, height equals 5 centimeters. Now I'm just going to verify that by looking at my net. Here we go. We have a base of 6 centimeters and a height of 5 centimeters. Okay, so that's all we need to calculate the area of this base. So area equals 6 times 5 divided by 2. Now again, make sure you've got your calculator out. Now I'm going to use mental math here. 6 times 5 is 30 divided by 2 equals 15 centimeters squared. Okay, but what do we have to do with this base? Well, if we look at the net again, we can see that there are two congruent bases. So we have to multiply this area times 2. So 15 centimeters squared times 2 is 30 centimeters squared. Okay, all right, let's look at the rectangles now that join the two triangles. Well, like we said, when we were doing a 3D view of this prism, we concluded that all three rectangles are the same. Okay, they have the same measurements of 7 centimeters by 6 centimeters. So let's go to the next step of our calculation. Area of a rectangle equals length times width. Length, we said, was 7 centimeters. Width equals 6 centimeters. Now, it's much easier for you because you've drawn the net here. You can look right at the diagram that you've drawn. All right, area equals 7 times 6. 7 times 6 is 42 centimeters squared. But again, how many of these rectangles do we have again? Well, we've got 1, 2, 3 that are exactly the same. 7 by 6, 7 by 6, 7 by 6. So with this area, we get to multiply it by 3. Okay? All right, let's use the calculator over here. 42 times 3 equals, and I got 126 centimeters squared. Okay, so does that take care of all the sides? We have the 2 triangular bases, and we have the 3 rectangles that join them. So I think that's all the calculations we need. So let me highlight these 2 answers. Okay, let's do the total. So in this case, we're only on step 3. Total surface area equals 30 centimeters squared plus 126 centimeters squared equals, let me check my calculator here, you can calculate it as well, 30 plus 126 equals, and I got 156 centimeters squared. 156 centimeters squared. Okay? Final conclusion statement. Therefore, total surface area is 156 centimeters squared. So you see that when we have an equilateral triangle as the base, it makes our surface area calculations much easier. Now the only other type of triangle that we haven't talked about is the isosceles triangle as the base. I wonder how that would affect our surface area calculations. Okay, thanks for watching. Bye.